All right, guys. So for 1-1F day 0, we're going to be talking about how to write expressions, right, with word problems. So for number 1 for our day 0 notes, it says Snapchat. Jimmy and John, because, Jimmy Johns, are eating and discussing Snapchat. Jimmy noted that he has 3 times as many snaps as John, and together, Jimmy and John have 16 unopened snaps. How many snaps does Jimmy have, John? Well, the first step is they want you to write an expression for each. So before I do that, I'm going to go in and I'm going to underline my key words. It says Jimmy noted that he has 3 times as many snaps as John. So that means he has 3 times as many snaps as John. Well, John must have S snaps then. So S has to be the number of snaps John has, because Jimmy has 3 times more than John. So write an equation to model this situation. Well, I know John's snaps plus Jimmy's snaps total to 16. So how can I solve how many each person has? Well, I know 4s equals 16. So if I divide both sides by 4, s equals 4, which means John has 4 snaps and Jimmy has 12 snaps open. So I always ask myself, what am I comparing this situation to? And I'm comparing Jimmy to John's snaps. So John is just S and Jimmy is 3S. Down below, number 2, Starbucks. Miss Fedorsky goes to Starbucks with friends. She knows a venti pumpkin spice latte is 3 times the cost of a regular grande coffee. A brownie is half the cost of the regular grande coffee, and a venti frappuccino is $1 less than a pumpkin spice latte. So step 1 is to underline the keywords in the word problem, which we just did. Step 2 is to determine what they're comparing the majority of the items to. So here, the pumpkin spice latte is being compared to the grande coffee, right? Here, the brownie is being compared to the grande, and the venti is being compared to the venti frappuccino, the pumpkin spice. So that doesn't really help us that last part, but the majority of the things they're being compared to is the grande coffee. So why don't we just make that G? So they want me to write an algebraic expression for the following. Well, the grande coffee is just going to be G. How can I write an expression for the pumpkin spice latte? Well, when I go back up, it says she knows a venti pumpkin spice latte is 3 times the cost of a regular coffee. So how can I say this is 3 times more than a coffee? Yeah, 3G. All right, what about a brownie? A brownie is half the price of a grande coffee. Well, if a grande coffee is G, then I know a brownie has to be 1/2 G. What about a venti frappuccino? It says the venti frappuccino is $1 less than a venti pumpkin spice latte. Well, for this one, a venti pumpkin spice latte is 3G. I'm going to subtract 1 from that one. Notice how I left those in parentheses. It's going to be very important that we do that, and we'll talk about why here in the days to come. Step 4, write an expression that represents how much money Miss Swiderski and her friends spend. Well, the grande pumpkin spice latte, or the grande coffee, plus however many grande coffees they have, plus she buys the pumpkin spice latte. We don't know how many though, so I'll leave that blank. Plus the brownie she buys, plus the venti frappuccinos, the 3G minus 1, is equal to her total. Okay, so really, I don't know how many coffees she buys. I don't know how many pumpkin spice lattes. I don't know how many brownies, and I don't know how many venti frappuccinos, but I do know that I can write an expression for all this. So what I can do is I can actually combine, my expression now, okay? I can combine my like terms. So I have a G, a 3G, a half a G, whoa, a half a G, and another 3G. So when I combine those, I get 1 plus 3 is 4, plus a half is 4.5, plus 3, 4.5G plus 3G minus 1. I can still combine those G's. So I get 7.5G minus 1 equal to my code for that. Okay, let's scroll down below. If Miss Swiderski bought 1 pumpkin spice latte, 1 grande coffee, 1 brownie, and 1 frappuccino, and spent a total of, let's say, $23.38, how much was 1 coffee? So step 5 is to plug in the numbers into the equation from step 4. So I knew it was something G plus, if I got 1 coffee, if I got 1, what was 3G? Venti pumpkin spice latte, yum, plus 1 brownie, which was 1/2 G, plus, I'll say I got the 1 frappuccino, so 1 times 3G minus 1, and I spent $23.38 approximately. How much was 1 coffee? Well, let's solve. 1G times 3G, so that's going to be 4G, plus 1 times 1/2 is 1/2 G, plus we'll have 3G minus 1 when I distribute that 1 equals 23.38. So now I get 3 plus 4 is 7.5 or 7.5 G minus 1 equals 23.38. Let's add 1 to both sides. So now I get 7.5 G is equal to $24.38. Now I need to divide both sides by 7.5. So when I do that, I get 24.38 divided by 7.5. I get G, which was my coffee, is $3.25. Well, if my coffee is $3.25, how can I figure out how much my pumpkin spice latte was? Well, let's scroll up. Pumpkin spice latte is 3 times more than that. So it's 1 expensive pumpkin spice latte. So if I times that by 3, I end up getting $9.75 for a pumpkin spice latte. I'm sure that's a big pumpkin spice latte. A brownie is a half the price of G, right? It was 1/2 G when I come back up here. Yep. So 3 times 1/2, or 3 divided by 2, is $1.62. A little bit more reasonable for a brownie. And a frappuccino was $1 less than the pumpkin spice latte. So $8.75. So hear me out. Really what we're doing, guys, is we're going in and we're reading the word problem and figuring out an expression from the word problem, right? So we highlighted the key information in here. We came up with an expression and determined what they're comparing the majority of the items to, which was a regular grande coffee. Okay, we came up with our expressions, an equation to represent the scenario. We plugged in our numbers. Okay, so we're going to be working on this here the next couple days. So as long as you remember, highlight key information, come up with your expressions, come up with a statement, we can plug numbers in to solve for our equations. So the next one we're going to do is this ratio problem. It says the ratio of boys to girls on B days is 3 to 2. If there are 180 kids on B days in 8th grade, how many of them are girls and how many are boys? Well, let's go ahead and say there are the ratio of boys to girls. So there are 3 times as many boys, 3 to 2. Okay, so every 3 boys, there are 2 girls. So I'm going to use X for girls. And I'm going to use Y. You know what? Here's what I'm going to do. I'm going to use X for kids. Well, I know there are 3 times as many boys to girls. So for boys, I'm going to use 3x. And for girls, I'm going to use 2x. So altogether, there are 180 kids on B days for 8th grade. So if I have 3x plus 2x equals 180, I can solve this situation. So the number of boys plus the number of girls is equal to 180 kids. Solve this. How many boys are there? How many girls are there? So I want you guys to solve that, and we will go over it tomorrow.